Okay, welcome everyone. Today we'll try to uh, prepare a power system model in ETAP software, and you can see the one-line diagram of a power system model, where we have some components. So if you look carefully, that we have two generators. So this is generator 1 and generator 2, you can say, and they are connected with two transformers, step up transformer, because you see this is the transmission side of the power system. So the rating of the transformer is written here as because the generator was 11 kV. So the transformer here is 11 kV to 132 kV. Similarly, for the second generator, the connected transformer is step up. It is converting 13 kV to 132 kV. The power rating is also given. For the generators, one of the generator is swing generator, as you know that one of the generators in a power system must be swing, and another one is PV type. So both of them are connected with a bus here. We call it bus A through circuit breaker. So we have multiple circuit breakers here. Then we have a transmission line, double circuit transmission line in the middle. Then it is connected with the second bus, which is bus B. And later there is the third transformer step down to 11 kV. Finally, with the bus C, our loads are connected. There are two loads. So this is a simple power system one-line diagram. So we'll try to make it in ETAP software, and we will run the load flow. Okay, so let's go to the software, ETAP software. We have ETAP software here. Like, we'll try to make it from the scratch so that anyone who is new in ETAP can also prepare the power system model. So this is ETAP 19. Let it open. Then we'll open a new file. So when we'll open the ETAP, it will give us the screen like this. So we will open a new, so let us give it a name, power system model. Okay, and let us save it somewhere. For example, here, maybe here we can open a new folder, power system model. Okay, PSM. We can give it a new name. Okay, it is not using the name, it is using new folder 2. However, we can just use this one, no problem, and give it a name. For example, power system model.oti, and save the project. Okay, so click OK. Okay. Okay. So the edit window will open now. This is the edit window. Let us maximize the edit mode screen. So we are here in the edit mode. So we'll bring the components we want to make this power system model. Okay, so we need two generators, and then 3 transformers, 2 lump loads, transmission line, and the buses, and so on. Okay, so we'll just try to bring them all. So I bring the generator and rotate this one. Okay, so I copy it. Sorry. So I copy and paste Okay, so for example, this one is generator 1. It's supposed to be our swing generator. Okay, so let's make it swing generator. And what is the rating of this generator? The rating is given 20 megawatt and 13 kV. Okay, let us select the rating. The other parameters are calculated automatically, you can say. So here operating values, what is the percentage of voltage? Let's select 100% of voltage will operate. And impedance model, we'll go to impedance model and we'll select the typical data so that it has all the data for resistance, inductance, and so on. Okay, capability curve, we don't need to do anything else. I think this is enough to model the first generator. Okay, so we click OK. Let's go to the second generator. We have what is the rating? This is 20 megawatt. Okay, and kilovolt rating is 11 kV. So 100% of the voltage should operate. And in the info, we make it PV. PV is voltage control. We go to impedance model, select the typical data, press OK. Okay, so the generators are given the parameter. Then with the generator, we have the circuit breakers. Okay, so we need multiple circuit breakers. Just select this one and press Ctrl R because we need it in the horizontal way. We need one here, and we need also two after the transformers. So let's put it together so that we can, and also we need one after the bus. Okay, in between the circuit breaker, so let's connect the circuit breaker and the generator. Okay, so after the circuit breaker, so we need to bring the transformer. Okay, two winding transformer. So this is the two winding transformer we have. So just put it here and bring the title on the top and rotate this one. Now carefully look at the value. This transformer, this is supposed to, okay, before giving the values, just copy and paste it so that your second transformer can be used as it is. So we are giving the rating. As you know that this transformer is primary should be 11, secondary is 132, right? Let us double check. 11 and 132, yes. So primary should be 11 kV and the secondary should be 132 kV. Okay, and MVA rating should be 30 MVA. 30 MVA. So like this nominal bus kV is empty because I haven't connected any bus yet. So it will come later. Okay. What you have to do else? You go to the impedance, select typical values, and also select here typical values. Okay. You don't need to do anything else. Click OK. So now I think you can connect and you can connect with the circuit breakers. Okay. Now go to the second transformer or another transformer which is supposed to be connected with the swing generator. Let us give us the parameters. So primary should be 13 kV. Secondary is 132 and the rated MVA will be 30. Okay, so go to the impedance, select the typical data and typical data. So just press OK and you connect. with the circuit breakers. Now, after the circuit breaker, you have a bus. So bring the bus and rotate it. Okay. So the rating of the bus, put it above. Now, you need to be careful about selection of the bus nominal kV, because you know that the secondary side of the transformers, these two transformers, was 132. So like the nominal should match with it, or we should support it. So we can put 132, or maybe let's put 140, so that it can be connected easily. Okay. So here we don't have to put any other parameters, just the nominal kV. So I connect, and then this circuit breaker connects with the bus. This circuit breaker connects with the bus. Okay. And this circuit breaker is the next circuit breaker. Let us bring it here. Okay, 140 kV bus. Okay. Now double check with the transformer to make sure that you are connected with the correct one. You see here for the transformer, it is showing that the primary is showing bus number 3. Secondary is bus 1, 11 kV. Okay, so that means actually our primary is here. It should be connected with bus 1. By the way, this bus 1 was not here before. Whenever we brought the bus 3, because each transformer is supposed to be connected with 2 buses in 2 sides. So before we brought this bus 3, there was no bus in the left side. You understand? Like if you click here, where is the bus? The bus is here, bus 1. You see the bus 1. You didn't brought it actually, but whenever you connected the secondary side of the transformer with bus number 3, bus 1 and bus 2 automatically appeared. Okay, but you can notice that the direction of the transformer is opposite. You see, like your bus 3 is here, which is actually the secondary, but here it is connected with the primary. Okay, so sometimes it happens, but you can easily solve this problem. How? You can simply delete this connection, okay, and rotate it. Okay, now you connect. So now you connect. You will see that, let us see, primary is with bus 4, which is here, okay, in the primary side, 11 kV. Secondary is bus 3, which is 140 kV. Okay, let us check this transformer. Primary is bus 3. Okay, so bus 3, secondary is bus 2, which is 132. Okay, so here it is actually having some issue. So we need to change it actually. So secondary should be bus 2, right? So let us delete this one. So it doesn't need to rotate actually. So let me see bus 2 and bus 3. Okay. So now if you save it, okay, so let us check now the transformer. So these transformers actually you have to keep checking before proceeding to any value. The primary is bus number 2, which is showing 132. And the secondary is 140. Why it is showing 132? Because the primary is supposed to be 11, right? Not 11, sorry, 13. Okay, so nominal bus is selected 132, so it is fine. I think it is okay. Let us proceed further, because the primary and secondary is looking okay, so it should be fine. no problem. So let's proceed further. We need to have a transmission line here. Okay, just keep the transmission line here and rotate this one. Okay, and then just put it in the middle, but you need a high voltage circuit breaker also here. Okay, and then you need a bus here. R, this will be your bus number 5, and that you bring another circuit breaker. You need a 2-winding transformer here. Okay, then you need again a circuit breaker, and you bring the last bus you have, and then 2 circuit breakers, or maybe you can just directly connect the loads. Okay, lump loads. What is the lump load? This is the lump load. Or use the circuit breaker to connect. Okay. Okay, let us put down the values. So this is for the transmission line. So for the transmission line, you have to select the type of transmission line from the conductor library. Select here metric, and this gymnastic, the last one, gymnastic type, you can select this one. Okay, but you have to go to the configuration, select a particular height, for example 60 feet, make the difference between each other like this, or maybe you can make it smaller. Yeah, this is total 60. And what is the length of the transmission line? Length is given in the question, 100 kilometer. Okay, let's make it 100 kilometer. Okay, and anything else? Go to the impedance, like positive, negative, 0. The values are automatically calculated, so I think they are all fine. Okay, so nothing left over here, just select OK. Okay, so now you can connect the circuit breaker with the circuit breaker. Before connecting with the bus, select the bus. So there is no transformer in between, so this bus can be selected 140 as well. Okay, 140, and click OK. Okay, fine. Then the next step, go to the transformer. This transformer is a step down transformer. It is 40 MVA. So be careful, select the parameters correctly. Okay, MVA rating is 40. Primary supposed to be 132. Secondary is 11 kV. Okay, and the impedances should be typical and typical. Okay, so that's it. Click OK. Now you can connect this, connect this. But before connecting, because the secondary of the transformer was 11, right? So this one, make it nominal value 11. Okay, 11 kV, because this is supposed to be 11. Yeah, because once you connect, it becomes 132 automatically. You will not be able to change. Okay, so it's better that you change it before you. So this is the first load. Put the load value. Okay, nameplate value. One of the loads is 11 kV 20 MVA. So MVA rating is 11. Sorry, kV. Rated kV is 11 kV, and this is 20 MVA. 20 MVA. So the other values will be calculated automatically, and I think nothing else you need to put. Okay, click OK, and you simply connect it. This one is the second one, and the last one is the another lump load is again 11 kV, and how much? 10 MVA. Okay, 10 MVA. So select OK. Now you can connect. Okay, I think we have done almost everything. Let's save this project. To be in the safe side, you can select here every 2 minutes it will save, and save connections for external use also. Save it. Okay, before we go for run, we need to double check our transformers. Okay, this is one of the transformers. Primary is supposed to be connected. Let's have a look. Primary is supposed to be connected with bus 5, and secondary is supposed to be connected with bus 11. So it is actually showing opposite. So we need to rotate that one. Okay, so delete it, and rotate this one. Okay, like this is one of the problems I think we face in ETAP, that sometimes the transformers, they're supposed to rotate. Okay, now let's see. Primary should be bus 5. Yeah, primary is bus 5, secondary is bus 7. It is okay now. It is okay. Let us check the impedance values. Yeah, we put all the impedance values, the typical value. Okay, so and this load and everything I think is fine. Let us double check. So generator is 20 megawatt, 20 megawatt. What we can do, we can increase the size of the generator a little bit more, to make sure that it supplies better power, okay, or higher power to support the load. Okay, so that's up to us. Okay, we can change if we need, we can change the parameters later also, no issue. So let us run it. Let's see that whether everything works fine or not. So we'll go to the load flow, PQ. This is the load flow. Okay, you can see this is the load flow, and we'll run the load flow using this. Okay, you can select untitled, no problem. Okay, so it is showing just one or two errors. So you can see the error in bus 2 and with transformer 1. Okay, so the nominal kV is out of the range. So I know what is the problem is actually, if you have noticed here, bus 2, where is the bus 2? Let's go to the, yeah, you see this bus 2. This bus 2 is connected with generator 1, right? So you see generator 1, what was the rating of generator 1? It was having a rating 13 kV, isn't it? So but important thing is that, before you change anything, this type of things, it's better that, you disconnect with the transformers. Okay, then you work. It will make it safe for you. For example, now bus 2 is connected with the generator 1, which is 13 kV, right? So we'll make it 13. You see 13. Simple. We'll make it 13 and then click OK. Okay. And just double check this transformer. The primary was how much? The primary was also 13, right? So just to make sure, you see primary was also 13. So it is okay. Okay. Now we can connect. You see, like we connect with this bus. We connect with this bus. You see, everything is fine, hopefully now. So I save it. Okay. And you can understand that, hopefully it will be fine now. Okay. I go to load flow and run this one. You see, like the load flow has been successfully running. So, and you can see the red numbers, which is indicating that what is the value of P and Q flowing from each of the generators. But, maybe you have noticed that, generator number 4, that means the upper generator, this one, it is not supplying any power because, generator 1, 30 megawatt, this is enough to support the two loads we have. You see how much load we have. This is 20, this is 10. So that's why, generator 1 is enough to support the load. But if we just change the parameter, for example, for example, this load, we increase a little bit more. For example, we go to nameplate 3, and instead of 10 MVA, let's make it 25 MVA. Okay, and click OK. So let's see what happens now. Go to the PQ. That means load flow analysis. Run the load flow. So you can see now it's still generator 1 is enough to support. So maybe we can increase a little bit more the lumped load 1 to make generator 4 active. Okay, because I wanted you to see that the generator 4 is also supplying some. Let us make it 30 MVA. Okay, so that will give a share of megawatt little bit higher. So click OK, save it. Okay, now let us run the load flow. By the way, one more thing to show here, that you can go to this edit study case, click here, and you can select what is the type of load flow analysis you want. For example, Newton-Raphson or first decouple or whatever, and you can select the maximum number of iteration, precision, and so on. Okay, so you have the option in hand to select those things. So just run the load flow now. You see, like it is not converging actually because we have selected higher values. So much higher. So it is not converging. It needs more. So we can make it smaller like before, no problem. Okay, I think it will work now. Yeah, but still, this generator is not operating. However, it depends upon the, different type of parameters that, which generator will support how much and so on. So once we'll study the load flow analysis, we'll see the detail of it. Okay, which generator will function in what way. So our basic objective was today to show you that how to prepare a power system model in ETAP and run the load flow correctly, and what are the ways to avoid the errors. So we need to be careful about selecting the bus, the bus voltages and the transformer voltage rating, and the direction of the transformer. The primary side and the secondary side should be selected appropriately. Okay, so you have seen that this power system model we had in the beginning, we showed you. So this has been prepared in the ETAP here, and we have run the load flow. So thank you. This was for today, and we wanted to show this for you. Thank you very much.